Hello, my name is Darren Thomas, and I am the Director of Educational Research Techniques. In this video, we're going to take a look at the behavior of the secant periodic function. So let's go ahead and begin this. So when we're talking about the word periodic, we're talking about something that recurs at a specific interval every single time. That'll make more sense in a second. But right here on this screen, you can see the actual equation for the secant periodic function. And so this should all look familiar. This A, B, C, D, this isn't all all the different functions we looked at, sinusoidal or even these periodic functions. And the difference is the use of this, whatever the function is right here is kind of what makes a difference. So in this example, it's the secant. But another one, we've seen tangent and also, sine and cosine as well. And so secant, in case you don't know, is basically, if you're familiar with trigonometric triangle or whatever, is basically hypotenuse over adjacent, or you could just say the reciprocal of cosine. So if you have cosine, this is not the best color, but a cosine is a over h, where h is adjacent and h is hypotenuse. So secant is the as you can say, it is the reciprocal of the cosine function, if you will, in many ways. And so, with the A term, B term, C term, normally, as we've talked about in other videos, this is going to represent amplitude, the A term, but the secant function doesn't really have an amplitude. So the A factor here kind of stretches or compresses the shape of the secant function. This will make sense in a second. Just please be patient. The B term is used to calculate the period. In this particular instance, is 2 pi over the absolute value of b. That should look familiar because I think tangent uses that as well. Or maybe it was the sinusoidal functions, I think is a better term, a better one. The the C function is kind of the phase shift to the left and to the right, if you will, and then the D kind of affects the vertical movement of the secant function, if you will. So that's kind of how it works. And of course, there are some asymptotes at x equals, let's see here, c over b plus pi over absolute value of b. This will make more sense in a second, but there's an asymptote. That means that there's like a curved line that almost touches a regular line but never actually touches it. But enough with the theory, let's see what this is like. So you can see right here in the upper left hand part of the screen, this is the secant function. This is just plain vanilla secant function where A is set to 0, C is set to 0, D is set to 0, and B is set to 1, if you will. So plain old fashioned one. And you can see here it loops up and then it disappears. There's an asymptote right here. There's an asymptote right here. You can see right there, and then another one right here. So it never goes past that. It disappears. And this is what's happening is that the denominator is being found to be 0. And so when the denominator is 0, you can't divide, and so that's why you have the asymptotes there. And so this is kind of what's happening. This is the normal one. You can see that it looks like it crosses the y-axis at 1, if you will, and then it has specific intervals. So this distance is always consistent, always consistent. That's what's happening there. So let's manipulate this a little bit and see how it acts. Now, the black one is still the regular old-fashioned one, and in this, the regular old-fashioned secant function, in this one, we're manipulating the A term. And so remember, the A term has to do with the stretching and the compressing. So you can see here, the blue represents when the A is bigger than 1. So you can see how it kind of compresses it a little bit here. And then, of course, the purple is when the A is less than 1. You can see how it kind of stretches it out. One of the things that's unique about this, let me slow down. And so you can see how it kind of behaves here. So when the blue is used, it kind of compresses up a little bit, and you can see the distance here kind of gets smaller. When you use a number less than 1, and you can see how the values drop here, and it gets a little bit wider, the space right here. And so that's kind of how the A term manipulates things. All right, so now with this one, we're manipulating now the B term. And so you can see here that has to do with the period. And so remember, the black is regular, what we normally get, and then the brown here, you can see that the period shrinks. In other words, you have more and more of these waves. In other words, they get close together and it increases the number of periods, if you will. Whereas with the red, you can see that it gets much wider, much wider here when the B is less than 1. So when the B is greater than 1, everything gets kind of compressed more here. That's what's happening there. All right, and so we're going to wrap it up with this. Again, there's not a lot of theory here. We're just trying to show you the behavior of these different functions, really, honestly. And so now we're with the green one, again, remember the black is just regular old-fashioned vanilla. With the green one, we're manipulating the C term, and with this, I guess, lighter green, if you will, we're manipulating the D term. And so you can see with the x minus 1, you can see that it moves. It moves to the right 1 unit. Okay, that's what happens. If I made this a plus, it would have moved to the left 1 unit. And so also with this bottom one right here, you can see that when it's plus 1, it goes up on the y-axis 1 unit. And of course, if I put a negative there, it would have went down 1 unit on the y-axis. And so this is just give you an idea of how this particular function behaves when you begin to manipulate the various terms. So let me go back and kind of recap what we did and conclude this video. So in this video, we took a look at the secant function. And we graphed it and we showed you how the different terms A, B, C, and D, how they affect and influence the behavior of the secant function, of secant periodic function. And so with the A term, it has to do with more stretching and compressing. The B term is used to determine the behavior of the period. The C term kind of works with the moving the term to or moving the function to the left or to the right. And then the D term affects whether to move the secant function up or down. And so also, in case you forgot, the secant function is just a reciprocal of cosine. It is hypotenuse over adjacent, rather when cosine is adjacent over hypotenuse. So I hope these videos made sense for you, that you were able to understand what we were talking about here. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.